Wow, good morning. So many geeks in the room. Nice to see all of you. Hello. As you already heard, my name is Rafał Lukawiecki. I don't work for Microsoft. I have never worked for Microsoft, but I have worked with Microsoft for 27 years. And that's a long bit of time. So I've seen a lot of different technology changes. In the last 14 years, I have focused on what today is called advanced analytics, data science, artificial intelligence, and when I was starting it, it was called data mining. Actually, this is not entirely new. We've had an awful lot of those technologies and approaches with us for at least 40 years or so, but it is becoming very popular, very easy, very important, and also very relevant to businesses today. And what I would like to do today is to share with you some observations how to make it even easier and more practical, because it is so popular today that there is an awful lot of hype, there's a lot of misinformation, and in particular there is a lot of kind of marketing-driven I guess, communication that makes people feel almost inadequate, that if you are not using the latest and greatest piece of software, then you somehow cannot do machine learning or data science today, which is definitely untrue. It can be very easy, very practical, and I hope to give you an idea about it in this talk. If you want to stay in touch with me, my email address, rafal@projectbotticelli.com, as well as my Twitter hashtag @rafal.net are at your disposal. So, what we are going to do is, as the very first thing, I am going to give you a little bit of a perspective on how data science and machine learning work today. I'll talk a little bit about the present, a tiny bit about the past, and a little bit about the future. But really what I want to share with you is how these concepts of ML, AI, data science all interact with each other and how they are going to influence not just the next few years, but probably the next few decades, not only in IT, but in our day-to-day lives. And you will be part of it. You will be building blocks of this change. So, a little bit of advertising, if you don't mind. If you are interested in studying it in more depth, I would be honored if you attended one of my 5-day hands-on intensive classes on the subject. You can find out the entire blow-by-blow detailed agenda on projectbotticelli.com/courses. However, my very last class of the year is next week in Oslo, so if you happen to be there, I think we have one last space available. Other than that, you may need to wait until springtime next year. I also teach online, projectbotticelli.com, and I would very much appreciate if you connect with me by registering for our soon-to-be relaunched newsletter at projectbotticelli.com/connect. And that is also the place where I have just uploaded all of the slide decks for the presentation that I'm giving to you. If you go to projectbotticelli.com, oops, where's my zoomer? If you go to projectbotticelli.com/PPT, which should be easy to remember, you'll see that I'm sharing the last 2 years' worth of my presentations there, and the one from this morning is here. Except, you know what every presenter does before you do a presentation? You end up changing your deck like 5 minutes when, you know, it's kind of exciting to do that. So I've updated it, so I will re-update the slides after the presentation. And in case you are interested in learning with us online, there's my collaborators, fabulous people who know everything about data analysis expressions, using Excel for BI in enterprises, building multidimensional analysis, Power BI, and there's me with data mining and data science too. End of advertorial. Okay, why do customers need all of this stuff? Why do they care about machine learning? Well, that's a question I had to answer for the last 14 years that I've been doing this. Or to be precise, I didn't know how to answer it about 14 years ago. I kind of figured out the answer maybe 9 or 10 years ago. And it's kind of amazing that over the last decade, the answer really hasn't changed. There are consistently 3, and not as consistently, 5 reasons why my customers want me to be doing data science projects for them. In the last 12 of those 14 years, my customers primarily hired me to discover reasons behind their successes and failures. They see that something works, they want to make more of it. Or they see that something doesn't work, and they want to avoid it. In fact, that is intimately linked to customers wanting to understand their own customers, their own products, and their own patterns of behavior. Looking for patterns is the essence of what we do in machine learning and data science. If you find these patterns, then you may want to try forecasting or predicting future. Accurately planning future is not the #1 reason customers hire me, but it is in the top 3 of those reasons. Planning future is exciting, but it's also difficult. You may want to practice your first data science project not on predicting the future, but on predicting the past and predicting the present. And I know it sounds a little quirky, so let me explain straight away what I mean. Predicting the past is extremely useful. What did happen that you didn't know? Was that customer happy? Was that sale possibly fraudulent? We often want to know what happened, and we don't have the data, but we can infer. We can predict with a dose of uncertainty what happened in the past. And today, we want to predict the present even more often. Have a think about the following typical scenario. In a large company, someone wants to know sales across the board. When do you know your sales across the board in a large company? If you're lucky, on Monday. Most of the time, it will be on Monday of the next month. Sometimes it will be Monday next quarter, and sometimes you don't know what your sales are until the accountants come in and say it's time to, do the budgets. Wouldn't it be cool if you could know what your sales are now, without having the data for it? What I'm talking about is that instead of waiting to aggregate all the information as we normally do to get an accurate or reasonably accurate number, you could predict what your sales are now based on some very well chosen, carefully selected data points and a model that joins them together. This has a name. It's called nowcasting. And if you are wondering, predicting the past is called hindcasting, and predicting the future is called forecasting. But those names are kind of recently invented, so don't necessarily worry about them too much. Yes, you can do all of that, as long as you are prepared to live with a dose of uncertainty. You may want to experiment with crazy new ideas before you take risks and use technology to help you decide what is right, what is wrong. And maybe you will take that first step into making autonomous, intelligent decisions. This is very exciting, but this is definitely early days. And of course, that is where artificial intelligence comes into the picture. So now that you know why customers want it, let me explain a little bit more what it is exactly that they get. Typically, they get a bit of data science, which is a loose intersection between technologies of machine learning, statistical analysis, a tiny dose of big data analysis. Nothing extraordinary about big data, thankfully, anymore. Big data became small, in case you weren't following the news. Big data, what's that? That fits on my iPhone now, so time moves on. And a huge, massive dose of data wrangling. Data is never in the format you need. That's not a question. It never is. Data is always slightly wrong, slightly incorrect. And if you dream that at one point in your future you will be handed good data, well, keep dreaming. You will always have to spend a lot of your time and money preparing data. 80% is the average amount of your budget you should allocate towards data wrangling. That's why tools such as SQL and SQL Server are the #1 tool of any data scientist on the planet. Not necessarily Microsoft SQL Server, but any SQL is, without any moment of doubt, #1 tool we use as data scientists. You can ask O'Reilly Media, you can ask Gartner, you can ask Stack Overflow, you can ask whoever you want for the Carl Rexer research for the last 10 years. That hasn't changed. But of course, you're here to hear about the exciting part, not the boring data wrangling. So let's focus on the exciting 20% of this picture, and we'll just learn how to do the remaining 80% some other time. Machine learning is an academic discipline which is also part of IT and computing that focuses on algorithms that detect patterns in data. Sometimes these patterns are interesting, sometimes these patterns are even useful, and sometimes they are interesting, useful, and valid, but that doesn't happen as often as it should. And I want you to remember that. Algorithms will detect patterns very often which are useless, invalid, or uninteresting. That's not a problem. The problem is when they detect a pattern which is exciting and invalid. You'd be surprised how often that happens and what kind of business decisions get made then. So how do we do it? Let me share with you the most borrowed slide from my presentations that I've been doing over the last 10 years, in every language of the world, in every possible combination of colors that PowerPoint can replicate. I've seen this slide now. Not every language, maybe 5, but that's okay, We always start with a business problem. You need to have a question. Then you find the data that hopefully helps you build a model that solves the business problem, as a result of which the data changes, and then the models have to evolve, and the business question changes. Have you noticed how I said don't start with data? Probably the second most frequently asked question I get when I talk not so much to customers, but to IT folks, quite a lot of you in this room, is, I have so much data, tell me what I could do with it. I'm sorry. Probably throw it away. Okay, I didn't say that. This is kind of, a bit at extreme, but there is a grain of truth in that. What you really need is to first have a need. And okay, if you want to experiment and find out some use cases from your data and do exploration, nothing wrong with that. But you are not going to succeed. If you want to be successful, the business, the need has to drive it. And even if you have a lot of data, you will almost always suddenly discover that you need new data that you currently don't have to build the models that answer the business problem you have. So if you have big data, that just means much more data to throw away. So you might just as well start with small data. I need 3 people to do it. The domain expert who knows what they want, the data expert who knows the data, and the data scientist who knows how to build models. I did try to be both the data expert and the data scientist a long time ago. I'm not good at that. I prefer to work with the best data experts I can find, and many of you in this room qualify. If you've been in business for a while and you know how to write a few select statements, that's a great thing to have. If you can optimize a database table, that's great, but that's not most important. The most important is knowing where in your company there is a table or some SharePoint list or some other utility or whatever that has the information that will help me build a model using which we will solve the business question. And that's a hard skill to find. Usually comes with a little bit of experience, but more often it also requires a few years of being in that company to know it better. So let me give you an example. Let's say, and this is a very typical project, you are tasked with identifying VIP customers. First question, what is a VIP? Well, the business says somebody who spends a lot of money with us over a long period of time. Good, 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 good. Show me a row of data, please, which has all the characteristics about the customer that we want and can legally, ethically, and morally analyze, and a column which says at the end, valuable customer. Oh, I don't have that. Well, this is where the data expert kicks into action and builds me a table that contains this data. This is not difficult to do. A little bit of searching is needed, but usually within a few hours we have it. Now I will build a model. Maybe I will use a decision tree. Maybe I will use a regression. I will almost definitely not use a neural network at this stage for reasons I will explain later. And I have a model which kind of so-so predicts the customer lifetime value. And the business usually doesn't like it straight away, so they slightly change the definition. They say, okay, not lifetime, but lifetime over the last 3 years. And maybe we only focus on that number and not this and this type of a customer. So we circle through this enough times until we deliver a model that the business says, this is exciting. We can start using it to drive our promotions. But truly, we will not know whether the model works until it has been put into production, when we see data, whether it correctly identifies and acts on its instincts. Well, that's more or less what I do. It's just those three things. All right. What has it got to do with artificial intelligence, you may think? Quite a lot. You see, the model changes the business. As a result of the business changing and giving better promotions, or not giving some promotions, or not giving some credit and giving different credit, or detecting which patients will need to be readmitted to the hospital, or more appropriately selecting machinery that needs to be somehow, fixed or oiled before it seizes, as in case of wind turbines in Spain. Well, all of that changes the world around you. Customers behave differently. The loans are different. You lose some customers, you gain some customers. The wind turbines stop seizing. Do you know what's happening now? Your models have to evolve because the data change. They become invalid, so they change. You change the models. And now your software makes a different decision. So yesterday, it would have said no to this customer. Tomorrow, it may say yes. As a result of that, the business changes, your competition reacts, and your models change, and the software makes different decisions. Software is perceiving its environment, and it's optimizing its chance of success. It's making different decisions because of it becoming more and more sentient around you. This is maybe not a very exciting, but this is a definition of artificial intelligence that you will learn pretty much on every major course on the topic since year 2000 or so. I studied that earlier. I studied that in the 90s with wonderful people who invented the programming language of microprolog and programming in logic, so my definition wasn't as well defined, but Russell and Norvig wrote the heaviest book on the subject, which is used for teaching AI. And for them, AI is a system that simply perceives its environment and takes actions to maximize its chance of success. And realistically, that's exactly what you are doing today. Do you know what's magical in this cycle? This. That line, which connects the change in business to the changing machine learning model. If you didn't update the machine learning model, it would not be AI. It would not be intelligent because it would be making increasingly worse and worse decisions. It's the fact that you are updating the models to reflect the world change that makes it intelligent. Some people call it artificial intelligence through the back door because it's kind of like the least exciting way to think about it, I suppose, but there it is. All right. My approach so far in doing that, obviously having started quite a while ago, has been to use three Microsoft tools. I have started with SQL Server 2005 data mining. Didn't really work well until SQL Server 2008 R2, about 7-8 years ago, and I still use it, and I'll give you a glimpse of it in one of my demos that are coming in the second half of the presentation. However, whilst it's very beautiful and highly visual, and I still use it on every project, and I will be using it probably for the next 5 or more years at least, it's not enough. I need statistical analysis. I need this elegance that modern statistical software brings. But above all, I want access to that 10,000 packages of statistical software that can solve problems that I don't even know I yet have. I'm not going to bore you with detail, but I was working on a project, fraud detection project in Denmark for the Danish pension agency, ATP, and we couldn't solve the problem, and I was searching for a solution. It was an oversampling problem, which we couldn't quite solve, and I searched and I find a package, and this package was called Rose, like a flower, Rose, and this package did random oversampling. Who cares about the detail? It solved my problem, but a light bulb appeared above my head when I did it. That package was only created 1 month before I found it by this very bright professor of applied statistics at the University of Padua. This lady and her team had a clever idea which made me successful 1 month later. And the light bulb said, that's amazing. Why would I want to deny myself access to all of those very, very clever individuals around the world who are solving problems for me this way? That's why I use R. R is the language in which you gain access to those tens of thousands of packages. R is a very ugly programming language. Okay, not very. It's kind of, it's like, there are these dogs which are not the prettiest, but you still love them. That's R. That's exactly how it is. So maybe I'll move on from that. I can't do my job without it. And today, if I want to use R, I will use a lot of open source R, but I will use Microsoft's R server, which recently became the Microsoft Machine Learning Server. But I also want to do things quickly and easily, and I don't want to build servers, and I want it to be very visual. So Azure Machine Learning is that third magic component of my suite of tools that I use on every project. I've been using Azure ML for over 4 years, and I find it an incredibly good tool for prototyping, for dealing with, we don't know if we want really to do that. Well, it costs like between $2 and $10 to get started. It would have cost me between $20,000 and $100,000 to do that 10 years ago without Azure ML. I hope Microsoft will maintain it for a very, very long time to come. Okay, let's rev up our discussion a little bit. Let's get a little bit more practical, and let me give you also some demos of these things. So first things first, if you want to be practical, you need to start with a business goal. I already told you that, but I repeat important things a few times. So let me just stress once again, don't start with the data, start with a business goal. Step 2, express it as a testable hypothesis. For example, the data we have can predict fraud, or promotion spectacular, spectacular increased our revenues. Something that you can word in a language that you can test using data, models, and a little bit of statistics, but more importantly, something that you will progressively refine from high level, where you said data can predict fraud, to very detailed, low practical level, my system X that looks at these customer characteristics in these data subsets can reduce fraud by 8%. Bear in mind, if you want to start at that level, you will fail because you don't have enough data. So you always have to find that high level of abstraction at which you can define the hypothesis so that it is testable. In practice, what that means is you define and initialize a machine learning model which you train with data, we sometimes call it processing, and then you do this incredibly important step of validation. The hardest thing to learn is not how to build a model. Anybody can do it. Anybody can push a button. The hardest part about ML, data science, and AI is validating it. And that's something you absolutely must learn. On my courses, I torture my students for 2 solid days out of 5 with nothing else but model validity and model tuning. That's really what they pay for. The first 3 days is just, warming up for that. Maybe that's not the right way to sell my course, so I'll just say that it's fabulous. Now that you have a validated model, you can use it. Explore it, learn from what it has to tell you, or deploy it into production and make it make some clever decisions. But don't forget, the model has to be updated. When you update it, it may go wrong, so you have to keep revalidating it all the time. Otherwise, you will end up with a model that no longer performs. So let me just rephrase that concept of progressive refinement. You started at a very high level with a hypothesis that the business says, well, this is a little bit trivial, but that's okay. Start easy. Start at a very high level. How do you get from that higher level to that lower level, to that low, detailed level of, I have built a system that reduces readmissions in this hospital? Experiments. And what is an experiment? Experiment is an observation of the real world which you somewhat change and affect by your model. That will cost you money, that will take time, and that will generate the best data there is. Only when you prepare data with a purpose in mind, you get the best data you can have. If you start with a big data set, you may find useful data in it, but it will almost always cost you more time and money digging for it than building a nice data set for a purpose. I'm a contrarian here. Most people say, that's old statistical guy talking about stuff that we don't do anymore. And they spend more money digging in big data for something, chasing their own tail until they find the answer. I'm not completely negative about big data. There are good uses of it too, but majority of them is hype. Let me give you a quick demo of old technology, which is easy, visual, and you already paid for it. You all have it. Well, why do I know that? Because most of you are Microsofties in this room, and almost all Microsofties have a SQL Server. And this is an example of a table that you have to build. It's not something that you get completely, for free out of the blue, but it's not very difficult to construct a table that looks like that. Customer 11004 bought a car from my fictitious company, then got neutral service, then a happy service, and then we haven't heard from them. Customer 11006 bought a car, got a neutral service, neutral service, neutral service, neutral service, and we lost the customer. Without going into detail how you prepare this type of data, everybody in the room, I know you can do it. What I can show you now is what you can achieve with this with a tiny little bit of dose of a technology Microsoft created more than 10 years ago called SQL Server Analysis Services Data Mining. Or to be precise, its full name is SQL Server Analysis Multidimensional and Data Mining, but we are not using any cubes. It's just that that technology comes with the same DLL where the cube technology sits. All right, you can use Excel to interact with it if you want. You can make it as non-scary as you wish. I'm collecting to my SQL Server Analysis Services server to show you a sequence clustering model which uses Markov chain analysis. Sounds modern? No, this is 15-year-old technology we've had over there for a while. One that clusters behaviors of the customers. Let me show you those behaviors. This is what they may look like. Let me show you the links between them. Let me just move it around into the order that is more likely to be of interest to you. 15-year-old visualization. Not bad, not bad. Can I do it in R? Can I do it in Python? Even the workgroup edition of SQL has it. Don't tell Microsoft I told you that. Did you hear that? You did. Even the workgroup edition of it has it. Okay. This is cheap old technology that tells me that 62% of my customers begin life with me by buying a car. Then I give 13% of them an unhappy service. I give about half of them a neutral service. And I give a rather lovely 22% of them a happy service. So what? So what? Look at this. I only lose 3% of customers who got happy service. I lose 11% of those who get neutral service, and I lose a whopping 20% of those who got unhappy service. And you can now say, well, that's kind of obvious. And that's true. But here comes the better part. Not only I can see this Markov chain, this is a Markov chain, by the way, where it shows loops and transitions like that, I also can see 11 clusters of behavior, how customers transition between these states. And the value of this system is that it can look at what happened to the customer so far, finds the cluster, and predicts what will happen next. And it also tells you not only the probability of customer loss, but why. By knowing where the customer is in this chain, you have the why. And that's so much better than just having a black box tell you, this customer will be lost. Why? That's more valuable sometimes than a black box, even if the black box sometimes can be more accurate. I'll give you a few more examples of that later. Let me just flash on the screen, very, very briefly, one of my all-time favorites, a decision tree. A simple decision tree shows you what makes, for example, VIP customers. My VIP customers are purple. Purple customers buy 4 cars from me. And I can see that I get most purple customers amongst rich customers. And again, you are saying that's something we've known before. That's true. But let's say you want to find your more successful chance of selling many cars in other income groups. What makes customers in this income group more successful? Well, it is the number of children they have. In this income group, it's how many children are at home. And in this income group, it's how far they have to travel to work. And amongst customers in this income group who have not between 2.5 and 5 miles to travel, the next thing that matters the most is the level of education that they have achieved. One way or another, there is a very exciting model behind the scenes, which I can also summarize by telling you that the most important driver of success is income, followed by number of children, education, occupation, and number of children at home. But, you know, Microsoft get upset if I talk too long about these things because this is an old technology. So let's move into the modern era. The modern era is that we need R, or Julia, or Scala, or Python. Because we want to use these modern technologies to give us a better feel for data, to discover correlations, to test importance of the columns while you are building a model, to validate your assumptions, and above all, validate your conclusions. Did it really work? Was promotion spectacular really successful, or was it just a fluke and I somehow achieved good sales, which I could have achieved without a promotion? And also to beautifully and precisely visualize information in ways that sometimes you cannot do in Excel. One way or another, we need software for all of that. So let me give you a glimpse of statistical charting using R. I would like to show you an example that has been anonymized from a real data set from a customer. I am using the Microsoft R server, but I really do not need to use the Microsoft R server for this demo. Even open source R would be more than capable of showing me the following visualization. This data shows weekly sales, quantity of products sold, and a price of the product sold. And a typical visualization that all of us will do at some early point in our career while we are visualizing price elasticity of demand. Oops, let me just load the library here. Sorry about that. And once again, that guy. All right, and a typical visualization is you create some scatter plot. The higher the price, obviously the lower the quantity of product sold, and maybe you will even draw a line through it, some kind of a linear regression line, which of course you could do also in Excel. But look at this, with just a few words, I can make this plot more and more exciting. For example, I could build a plot that shows not only that linear model, but also a smoothing line and a density plot. I really like density plots. They show me, like a contour map, the peaks where my customer is concentrating their efforts in terms of trying to make the best price judgment. And when you see a plot like that, where all of the lines crisscross, and you see that most of those pricing attempts are concentrated in an area where the market forces represented by the red line intersect with customers' attempts represented by the smoothing line, I know this customer has been in business for a long, long time, for a few hundred years, in fact, for this company. When you do this plot and everything is all over the place, you know that they need some help. 3 lines. I could not do that easily in the past. And I can recycle this code over and over. This is easy. This is practical. This is simple stuff. This is not deep learning and some framework you just heard, you know, in a newspaper yesterday about. However, sometimes you want a little bit more. And sometimes you want to build these machine learning models in ways that don't give you time and money to build your data center with servers and hire qualified data scientists. Well, this is where Azure machine learning comes in. Today, it's a very powerful, graphical, user interface only, non-scriptable, unless you want to use R, environment for quick and super easy deployment of web services that are based on machine learning models. Microsoft are currently re-engineering it very thoroughly, and the next version, which we will have in a year, or maybe longer or shorter, but quite a while, is a dramatic change. It will be not GUI-driven, but it will be code-driven. And rather than giving you a framework that Microsoft created and invented, Microsoft will let you choose the framework for machine learning that you want to use. And there are many of them. There are over 500 machine learning frameworks in existence, of which the most popular is TensorFlow, created by Google, Spark ML, which is part of the Apache project, and Microsoft's very own cognitive toolkit, also known as CNTK. Building your machine learning models in these environments will be possible with R, with Python, with any of the other languages you want to use, but the current preview, which is already available today, only works with Python. However, let me show you a glimpse of that technology in its currently released version. Not the preview, but the one that I have been using now for quite a few years. What I would like to show you is Azure Machine Learning, and Azure Machine Learning Studio, to be precise. This may look complex to you, and you just have to trust me on that this is not complex. This is what everybody builds by day 3 of my course, and you kind of think like, yeah, you know, this is so obvious. It's an environment in which we import some data from SQL Server, data about our customers, and after a little bit of preparation of that, we build a set of decision trees. I could show you these decision trees. They are a little bit more complex than the decision trees that you have seen in SQL Server analysis services when I was showing them to you using Excel, partly because there are 20 of them in this case, not just one tree. This is known as an ensemble of many trees. Instead of using one tree to make decisions, you have a forest of these trees, and they all make decisions, and they vote on the result. This approach is far more accurate than the older approaches, but it is not as easy to understand. And yes, I could go into this incredibly slow-to-load visualizer to show you what is in the trees, but I'm going to skip this part because it's not as important today. What's important for me to show you is that you can also validate and evaluate these models for correctness. And the model I am building here is extremely accurate, almost crazily so. If you see curves like that, that means that it's a little bit too good to be true. But that's because it's sample data which we teach with, and we want our students to be happy while they are building these models. So it will make it a little easier. Most of the models you will build will have a curve somewhere here. Maybe curve even somewhere here will be good. And if you ever touch this point, known as point of perfection, you've built a perfect model, and that means you made a mistake, because perfection is not attainable. 30% of my students during the course make that mistake. Anyway, what's my point? You could then take all of this stuff and you could nicely wrap it into a web service. You could nicely wrap it into a web service, for example, which one do I have over here? This is a good one. And let me show you what that looks like. And that whole complexity of model building is now embodied in this one, as we call it, module. Those boxes are called modules. So everything you've seen earlier is here. I stick some input from a web service that calls it from an invocation. I use my model to make some predictions. I beautify the answers, and I spit out the results using the web service output. This is simplicity in itself. It is totally uncomplicated. And in order to give you a glimpse of how this web service works, let me just go back to the previous page before I loaded it. This is the API key. And over here on this page, there is code that shows you how to implement the invocation to this service, should you want to do that, in 3 programming languages. You get a sample in C#, in Python, and in R that you can use to invoke this service. And what I am going to do is I'm going to use, I copied and pasted basically a little bit earlier, that little bit of code in Python, and we're going to run it to run this service to see whether a customer would or would not be a VIP. By the way, the environment I am using for running it is known as a notebook. Notebooks are a cool way to quickly test your things as you are building them. Let me just make sure I have cleared all the previous results. So you see fresh results. Notebooks are basically like a console on steroids. What you type is what you get, and I can do things like 3 times 5, and I can run that cell, and it tells me 15. That means it works, okay? It does. If you get a different result, you need to upgrade your software. But more importantly, this is where I stick some data about a male with good income who is married, has 4 children, 3 at home, partial high school level of education, a manager, owning home, living 5 to 10 miles away, who has 45 years of age, and I want to find out, is he a VIP? So I am simply going to package that data, which is in JSON, into a body of a URL request, and this Python library calls this URL, which you may have noticed earlier was the endpoint of the Azure ML Web Service, waits a little bit and prints the result. So let's run it, and that's a little bit slower than usual. Normally it comes almost instantly. I'm a little bit surprised it took that long. And what's the answer? False, not a VIP. The probability that this customer is a VIP is at 4.2%. What could you do with that? Put it into an app and decide that this customer does not get the golden promotion. You could put it into Excel. You could put it into a website on your intranet. It's as easy as just calling a web service, and that's why I like Azure Machine Learning so much. It's so quick to go from an idea, I have some decision trees, bong, 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 and I have a web service I can deploy into applications. And you have to trust me, it runs usually much faster. I know why it wasn't that fast, because I haven't run it for a while, and if you don't hit a service for a few days, Microsoft puts it into deep freeze, and the defrosting period takes about 1.5 seconds. If I had time, which I don't, I would prove it to you. So, let's move on with this subject into the next aspect of the era of modernity, is that now that you like all of this stuff, R and Python and all of that, you'll probably try doing it on large amounts of data, and you're going to have an oops moment. An oops moment because R is not designed, or normal R has never been designed to work on large data sets. Python is a little better, but not that good either. Well, this is where Microsoft came in about 3 years ago and bought a company called Revolution Analytics to give R and now Python superpowers. And those superpowers give it scalability, parallelism, no need to move data because everything can happen in your favorite database, and all of those Microsoft enterprise abilities, manageability, securitability, and everything else that we need to make it applicable in a commercial enterprise. What I would like to just focus on for a second is just how much you get in it today. There were times when I wanted to use R on 100,000 rows of data, and I couldn't do it. I well and truly over. Using Microsoft ML package, which comes with now it's called Microsoft Machine Learning Server, and until 2 months ago, it was still called the Microsoft R Server. Using the Microsoft ML package, I can build models on 1 billion rows by billion columns on one server. I can use NVIDIA graphical cards, up to 8 of them, on a server to build a neural network using RX neural network on 10 million columns and an infinite number of rows. That kind of ability computationally is pretty staggering, and it's exciting, but don't think you need it. It makes it sell, which is why I'm showing it to you. You typically don't need all of that power. You typically need something much smaller and much simpler. But just in case you needed more, you can. And that's nice to have. Assuming that you must have this amount of data to do anything is wrong. Start with smaller data sets, not the big ones. But the tools allow you to go big if and when you are ready for it. And you will be at some point. Let me give you a quick example of Microsoft R/Machine Learning Server, which makes something that used to be very complex very easy. Sentiment analysis usually meant building a complex neural network, blah, blah, blah model. Well, Microsoft now ship pre-built model in every SQL Server 2017 and in every SQL Server 2016 if you have installed the Microsoft R server and you are properly licensed. Properly licensed means developer edition, enterprise edition, and some usual Microsoft nonsense about everything else in between. It's very easy to do it. This is how you do it. 4 lines of code. There is no magic. That's all there is, these 4 lines of code. Stick some data into what we call in R a data frame. Data frame is just a table. So I have 4 sentences. Then use the Rx featureize function to get sentiment of that data. And I'm not hiding anything here, you see. It's not like all the cool stuff happens after column number 80. No, that's all the code there is. And then extract the ratings and print them. In R to print things, you just put the name of the thing you want to see. All right, so let's run this code. Let me execute, let me just execute all of that. And it will take just a moment to launch itself. It's running in our server, and well, it looks like pizza was good is the happiest sentence here, which makes sense. This is a conference, I'm sure, 50-50. So let's say that this is a great SharePoint Europe conference. Shall we rerun that? Remember, that was 50-50. I haven't done this one before. I used a different one before, so I'm kind of also interested to see how, oh, look at that. 88% of awesomeness. Clearly, SharePoint Europe makes the model work, but let's stick an exclamation mark at it, okay? Remember, 88% is the score. Let's rerun that. In production, that will be faster. Wow, from 88 to 92.8, 93% of awesomeness. I mean, what could be more awesome than SharePoint Europe conference exclamation mark? Put more exclamation marks. Well, let's see. Let's see. You remember 92.8%? No. 1 exclamation mark is more powerful than multiple. I tried that one before. But of course you understand it. People use lots of something when they don't often mean it as much as when they think it through. Microsoft built this sentiment analysis model from billions and billions and billions of data points on Bing. And it's all in an 87 megabyte file that's well hidden somewhere under C program files. I could show you where, but I am not going to because I don't have time. As long as you have installed the R server, ML server. No need for you to build anything from scratch anymore, as long as it is in English. If you want other languages, you'll have to wait a little, or you'll have to figure out how they did it and do it yourself that way. But soon you will be able also to do it all in SQL Server in all the languages Microsoft supports. So this is a quick example of this new era. Not so visual, not so pretty charting and so on as the old era, but pretty powerful. Deep learning. Oh dear. Deep learning, deep learning. It's so overrated that if you were to blow on it, it would explode, okay? Basically what big data used to be 5 years ago, who talks about big data today? Deep learning is today. In 5 years, mark my words, it's gonna be like, oh, whatever. Deep learning is just a computing optimization. Basically, deep learning says that you are building a neural network with multiple layers, where everything is connected to everything, therefore it's deep, and what happens then? It never finishes running because it's too complex, so we need to optimize it. And this optimization process is where deep learning comes in. It is useful, but because it is so intimately attached to neural networks, it is also opaque, it is also often a black box, and that also means that it is very frequently impossible to understand why and how it works. So let me show you an example when it is used for a purpose that makes sense, and when we don't care about understanding so much how it works, and then I'll talk about some issues and some concerns I have. So for this last demo, I am going to show you a neural network, a deep learned neural network in Azure Machine Learning. Let me actually show you kind of what it looks like. This is the idea that I have neurons representing handwritten digits, and I have some hidden network inside where magic happens, and then I have this output neuron which tells me what was the number the person wrote. Was it a 0, 1, 2, 3, 1, or 9? That's all, okay? The reason I'm showing to you is because it's a demo you can all access from the Cortana Intelligence Gallery from Microsoft. It looks easy. This is the data set. Let me just show you that data set. The data set is 60,000 hand-drawn numbers. Do you see it? Okay, what are we looking at? 785 columns. Pixels. This is a 28 by 28 pixelized image. Each column is a pixel. That's how we do image analysis. In case you are wondering, everything becomes a column in a database. That's why we end up with millions of columns, all right? Yeah. So in this case, it's a low-resolution image. So if I have a 10 megapixel image, yes, you need 10 million columns. Oh, okay. Can you see the hand-drawn numbers? 0 means there was nothing on that pixel. Let's look. I usually can find something. Oh, yeah, there. I got lucky, I got lucky, I got lucky. So the values go from 0 to 255. 255 is a full width stroke, 132 is half gray, 12 is barely there. This is a left-handed person. Can you see that? Well, of course. The pencil is slanted towards the left. The stroke is heavier, the 132 on the left, than on the right, the 12. It's just pixels. So can I, from these pixels, figure out that this person actually wrote a 6? So that's how the data looks. Feed it pixels, feed it answers, train the model. How do you train the model? You initialize a multi-class neural network with this little script which does a little bit of convolution, a little bit of pooling, and a little bit of magic, where we say, give me 100 neurons on level 3 connected to everything on level 2, and then connect 10 answers. Why 10? 0, 1, 2, 3, 4, 5, 9 to that 100 neurons on hidden level 3. Only 88 lines of code. I know, it's not very straightforward, but you could learn it. This is not hard stuff. Honestly, this is not hard stuff. People make it much harder than it is. And by the way, what I'm showing you is too complex. You actually don't need that level of complexity to solve it. But this is a good example to show because it performs very well. After I train this model with my 60,000 images taken from a very well-known data set that's used for competitions and so on, I will test it on 10,000 images which were not used to build the model. You see, the model was trained from a data set here, but I am testing it using a different data set. And then I'm evaluating the results. I'm going to show you the results of the evaluation. It's just a matrix that says, this is what we detected, this is what we saw. I wonder if you can read it. I hope you can. So for example, let me just make it a little bit bigger. So for example, over here, you see that when a 0 was drawn, 0 was detected 99.6% of the time. That's a great result. When 1 is drawn, 1 is detected 98.8% of the time. This works pretty well, but it makes mistakes. It confuses occasionally some things with a tiny, tiny dose of probability. The most struggle it has is, I think here, I don't see a 0.6 anymore. 0.5s, confuses 7 and 8 with a 9, which you can understand why. 9 and an 8, how often we draw it very carelessly. A perfect model would have 100% along the line in the middle, along the diagonal. All of these empty spaces are great. That means no mistakes are being made over there. The overall so-called accuracy of this model is a 99.7% accuracy. Yes, you could use that for handwritten check recognition. This is how car tolling works, where at high speed a car goes and a camera snaps the image. And how does it cope with mistakes? Well, a human has to fix it to retrain the model. And that usually happens in another part of the world where people look at a screen and correct things. But each time we fix it and we feed the data back into the model, we build a new model and it becomes more accurate. You remember that cycle? Oh. It's all coming together now. So, is everything perfect? No. We have a dilemma. We call it the black box dilemma. The problem is that you don't just got excited with these neural networks and deep learning, but there is a nasty thing about them, very nasty. Unlike those simple decision trees, linear regressions, and sequence clustering with Markov chains, we have no idea why they make decisions. No idea. Any real-world deep learned neural network is a black box. So you ask it, what is this digit? And it tells you what the digit is with a small dose of incorrectness. Well, that sounds like a good use. You talk to your Siri, and she gets it most of the time, and that's great. And you use Cortana, or I don't know, you use perhaps translate.bing.com, or you talk to Skype, and it translates your voice, and we are all happy. But what if it is driving your car and it decides to turn the wrong way? What if it's saying no to a customer who should get a loan simply because this customer looks wrong? Well, actually, let's focus on that. Let's say you build a model which says, no, I'm not giving you a loan. And the customer calls and says, why not? You will have to answer, computer says no. And that's the problem. In fact, in majority of countries in European Union, it is illegal to build a neural network-based system for credit scoring. You can do it in Norway, by the way. They haven't quite figured that out yet. But anyway, my point is that I'm very worried that we are building increasingly more and more of these overtrained, impossible to understand, very clever things, and they seem to work, but we don't know how, until they break, and that's the problem. Invariably, if you don't know how it works, sooner or later a time will come when it will fly in your face the wrong way. Not the last two, but the previous 3 flash crashes on NASDAQ. That guy in Singapore who went to prison for losing his big bank's money, maybe even Lehman Brothers to some extent, although that's probably a stretch. Tons and tons of examples of overtrained, highly clever systems that suddenly make better and better decisions. You give it more and more money, and eventually, it's like gambling more and more and more, and suddenly they make the decision in the wrong direction, and you lose everything. That's going to cost us. I hope human lives will not be lost. But I know that companies will definitely go out of business in the future because they will try to do things which they shouldn't do. However, I want to leave you with a more positive thought at the end of this presentation. So let me focus on a few things you should do. Value meaning and understanding above all else. Human intuition and common sense is better than advanced neural networks. Start with easy, practical, business-focused projects. Avoid deep learning in the early stages. Keep it simple. Eventually, maybe you will use it for things like image recognition or voice or text. Expose anything you build within your company using a web service so that you can consume it and make it better by closing that loop. And as you keep closing that loop, make sure you keep validating it, because we want you to build intelligent intelligence and not artificial stupidity. And remember, algorithm is never the magic bullet. It's not about finding the best framework or the best language. It's all about good data, usually smaller than bigger, a lot of common sense, a lot of trusting you and not the machine, and starting as simple as possible. I can't remember who said that. It was a thinker, great thinker. Eschew surplusage. Sounds kind of cool. Remove the unnecessary things, focus on the core of your question, and I am sure that your machine learning projects will be easy, fun, successful, and also useful and profitable to your business. And with that thought, I would like to leave you with a couple of URLs. I hope you will want to stay in touch with me, projectbotticelli.com/connect, relaunching our newsletter this weekend, my 5-day classes, projectbotticelli.com/courses, and PowerPoints at projectbotticelli.com/ppt. Other than that, I understand that there is some exciting prize giving to happen right now, but as far as I am concerned, I would like to thank you all very much for your attention and wish you a pleasant day on this beautiful Dublin morning at the wonderful, awesome European SharePoint conference. Thank you.